Hi there, this is Jeff Clarkson, and it's been a little while since I've talked to you folks, and now I'm trying some video training. We've brought some new features into the Ultra Analytics interface program, and in fact, some of them require that I present them a bit to you and train you a bit in them. And I know sometimes we've done this with live meetings, and I know that we can present this in a way that you can watch it at your leisure rather than trying to find some kind of coordination. So what we're dealing with is in fact a couple of changes, and here's the agenda for this meeting. This is to address changes that have been made for interface version 6. You can see the 6 at the top here and all those other numbers afterward, but 6 is the really key one. That's what that version number change tells us that some training is required. First one is that there's an overview of changes in the Ultra Analytics asset definition. We talk about materials of construction now. We have a vessel inspection plan modeled a lot on the piping inspection plan that you're all familiar with. We also are able to select vessel and piping standards, and we also include for vessel dimensions. That's to help us with some better evaluation and hopefully give you guys some more tools to work with. For data files, there's a couple of updates. The first one is we've introduced something called a bare transducer reading, and we need 2 of those in each file. We've also introduced the reduced aperture delay line, or the RAD line. That actually you've been notified about by Joanne, and I'm going to talk a little bit about those, and the bare transducer readings are really there to deal with those. We've also added the opportunity to be able to get repad readings from multiple small nozzles or multiple small repads, for instance, ladder repads on a vessel. And I'm going to talk for a little bit about the data check. There's a couple changes there. We actually need to make some changes and updates on that. So in fact, I'm going to be telling you don't worry as much about it as you have in the past. Okay, so for materials, let's talk about the materials changes. And one thing is that we're talking about reinforcement and resin, and as well something called inorganic fillers. What does this look like on the asset information page of the interface? Well, I've just happened to have one here that I put together. This is for a vessel. And down here you can see this little box, asset materials. And in fact, there's a pull-down menu for reinforcement material, and we can select what reinforcement material was used. Chances are, in a lot of cases, it will be unknown, but we might know what kind of fiber was used. It might have been carbon fiber, might have been E-glass or ECR glass or Owens Corning Advantex. Or it may be some other, at which point we would click on that. And when we click on that, it actually gives us an opportunity to write in a specification for the other material. The reason for this is that different reinforcement materials have different reactions to various environments. For instance, an acidic environment does not get along very well with an E-type glass or an ordinary E-glass. And it's important for us to know that so that we're able to fine-tune our database and our analysis. The same thing actually goes for resins. Resin, in fact, is thought about even more than glass is. For resins, as you can see, we also have a fairly extensive drawdown menu that includes a fairly wide range. We can be unknown. And as well, if it's not listed here, we can click this. The resin's not listed above. We could put another name in here, and that will be stored with the asset file. The other thing, and we ask about inorganic fillers. An inorganic filler is something like some pipes include sand in the middle, and it's used for some structural reasons. As well, in the corrosion barrier, there may be some material called silicon carbide or silicon dioxide. It's for abrasion resistance, and those are important pieces of information to have. If we don't know if there's inorganic fillers, that's often, that would be almost to the point that we say, no, there isn't any used. They're not that commonly used. Pipes will most often have sand. Some pipes will have sand. Buried pipes will often have sand. Within the rest of the asset information, you'll notice we have an inspection plan reference. This is generated, normally this name is generated by the software as soon as we create an inspection plan. So onto the inspection plans, and let's talk about them. They are very similar to piping. They're to the point that, in fact, we still use the term CML, and we don't show them quite the same way on. We show them exactly the same way as we do on piping, but we don't show them a different way for vessels at this time. You can use scans, just like for piping inspection plans. You can use a scan, you can use a photo, or you can use the images provided. You know, where you select what kind of vessel it is, the images that come up there are automatically inserted into the inspection plan. So for instance, when we're dealing with the vessel, if I click OK on the asset information now, because this is all correct, it will ask me first, before I go any further, it does ask, the asset information has been changed. Do we need to confirm that with the inspector or the owner? In this case, I know that no, we don't have to confirm any of these changes, and so that's fine. If you do have to confirm them, it'll be your responsibility to go to the inspector or the owner. So when we get the inspection plan, I'm going to move it into the screen now, and you can see, in fact, that it's big. Remember, for piping, when we had inspection plans that were, if they were big, then we had to move them around with these arrows. Well, in fact, if you just place your mouse in the middle, oops, I'm sorry about that. Okay. I have, there, I'll fix that, there. When you just place your mouse in here and scroll on the thumb wheel or on the scroll bar, you can see you can make that all fit within there. It'll scale itself. So what happens is that we've identified on this vessel 2 condition monitoring locations. You'll notice this is the image that gets shown to you. What kind of vessel do you have? And in fact, when we click on the CML or condition monitoring locations, CML1, shell at 0.5 meters elevation, yes, there's ultra analytics data present. And in fact, as we scroll through, we have lots of opportunities. We can place a sketch into the file to show us where to take the readings. We can place instructions. In this case, I've written readings all around. Notes and observations, probably from the inspection. And we can even add some photos, and these would all be included with the inspection plan. In order to add a CML, I did that accidentally a minute ago. I'm going to actually add one. We actually just click on the image, and you can see that down in here, a 03 appeared. And when that appears, we get this little window that comes up. CML is 03. We can copy information from another CML should we wish to. And in fact, this one is a little bit different. Just as a background, CML2 is for the manway repad. CML3, I don't have a picture of the nozzle here, but CML03 is for a small diameter nozzle. And when I say small diameter nozzle, it's for a nozzle smaller than 12 inches, and we'll cover a little more of that later. Is Ultra Analytics data present? We'll say yes. The section name, shell at 0.5 meters, and my keyboard's not working, at 0.5 meters. And the repad name is, let's call it nozzle N1. And so we can add that CML. At the, and so therefore it's pretty easy, straightforward. CML 01 is for the shell at 0.5 meters. CML 02, shell at 0.5 meters elevation, and it's for the manway repad, and so on. So this is now complete. This information, by the way, yes, changes have been made to the inspection plan. This information, by the way, will be placed in the report, just like it is for piping. You know how when we issue a piping report, we say, here's what inspections were done. We can also save it for future use. Remembering for piping, you can save a copy of the XML file. You can also save Word files as worksheets. The next thing is that we actually have some opportunity for some pull down standards on the piping. For instance, it comes up in the suitability for service. You can see vessel is in original service or same service since last inspection. Yes, no, unknown. Vessel design and construction follow generally accepted standards or specifications. And in fact, we are able to identify the standard that was used. In this case, I've used ASTM D3299. We also have some others. We may actually have yet another that that is not included in this list. And as we get more and more, as we get information that we've never had before on these things, we have opportunity to add these others into the interface software. And that's information that will update automatically when the definitions for your software are updated. And if we don't know, we can mention that and say none, of course. The other thing is, and I'm not sure if I've covered this before, vessel contents. You'll notice we now have a pull-down menu for vessel contents, which is extremely long. But I'm going to offer some thanks to Ashland Chemicals because they actually provided us with this list. We're able to identify the concentration of the materials. If the information is not in the list, and I think it's listed here at the very top, we could put other. When we select that, we are able to write it in this particular window and identify what it is. Operating pressure, this is an open top atmospheric tank. So there will be internal pressure. The internal pressure even could be 0, but we've just put 1 kilopascal. The external pressure, there is none. You could put 0 here. That would work out fine. So those are some updates to the suitability for service. The standard, remember, the standard for construction should be included on the drawings and should also be included on the nameplate. It's not always there, but it should be included in those things. And don't forget, don't be afraid to tell us you don't know. Vessel dimensions are something that we've also added. This will be used to improve analysis. You should be able to get this from the drawing or from some relatively quick field measurements. Generally speaking, we'll be looking for diameter and height. There's a couple of other things that may be different when it comes to a rectangular vessel and maybe a horizontal vessel. Also, remember to provide actual operating pressures in the suitability for service data. If you have a vessel with a closed top and there's pressure inside it on top of the liquid, so that would be a pressure rating or pressure vessel, then please tell me what that pressure is. That helps us because we're able to make sure we back check and provide better support. There's guidance for this in the data collection standard FRP vessel dimensions on the licensee page of UTComp.ca and UTComp.com. They go to the same place. And in fact, this is a vertical cylinder, so I'm going to show you what you get. The measurement units in this case, we're listing meters. We can use millimeters, feet. So I've gone to feet. The tank diameter has changed. We don't actually convert it. We actually convert it mathematically afterward. But we can use feet, we can use inches. In this case, we've measured it to be 2.44 meters, which is really 8 feet, and 3.66 meters high. So that information is used, and ultimately we'll hope to be able to provide you with some additional information on the interface to use that. Next slide. Now, data file updates. The bare transducer. Taking a look at this picture, we want the first and last readings of every file to now be bare transducer readings. Remember, what you've been doing so far is the first and last readings have been transducer calibration readings. Well, the transducer calibration readings still remain, but the bare transducer readings are the reading ahead and the reading ahead of the first calibration reading and the reading after the last calibration reading. So the picture on the screen shows a bare transducer. You can see the transducer here beside the flaw detector, and you can see delay line and a rad line in front of it. Transducer is cleaned of all couplant, and we've increased the gain to the maximum value to show all of the peaks with nothing clipped. That's actually really important. It's good information, is necessary information, particularly with some of the new calculations that we're doing. You want the zero and the range for the bare transducer reading to be the same as for the inspection. I know that range can change, and in fact, we're able to work with that a lot, just in case you have to change the range. But at least one of the zero and one of the bare transducer readings has to have as much range as the longest range of the readings that you use. And as I said, use your maximum gain with no clipping. There are certain features in the readings that we can actually explain with this, and we've actually we've had to work with this in the past. So now, this is repeating again. The file structure becomes bare transducer, calibration reading, inspection readings, calibration reading, and the bare transducer with the same range as the maximum range used for the inspection readings. Okay, now the rad line. You've seen this before. Some of you have actually purchased them, and we have some available. This is for FRP with a radius of curvature less than 300 millimeters or 12 inches. Another way to think of it is if you're doing a piping inspection, any piping smaller than 24 inches or 600 millimeters outside diameter is to be inspected using a rad line. The maximum range that should be used for this is 50 microseconds. Any longer than that, and first of all, it doesn't make sense that the FRP would be that thick on piping. We actually test each rad line here before we ship it to anybody. We make sure that it meets the requirements that we have. We have these specially made for us, and we've been pretty happy with the ones we've got. We've actually used some that were made different ways and they did not work. It's really important for you to know that. Now you'll notice on the left-hand picture, you can see a picture, we're looking head on at the rad line, and we want to align the long axis of the rad line, or the long sides of the rad line, with the axis of the tube or the pipe. The reason is that we're maximizing how much contact area we can get. The picture on the right shows an image of that. You might be able to see on the, you might actually be able to see that the rad line is lined up along in the same direction as the axis of the tube I'm showing. The display on the Olympus unit is showing the reflection. The actual back wall reflection is about almost halfway across the screen. I'm showing a little extra range there, but that's okay. And so that's how we work that. The next thing that we've got to add is multiple small nozzles. The other thing is, and this can also come from multiple repads. I've actually built this for multiple small nozzles. But readings from several small repads can be grouped into one file. And for nozzles, you actually have to use you can only really use this feature if the nozzles are less than 12 inches or 300 millimeters. One of the things that happens is that each time, what you should do is that you should make each repad a CML in the inspection plan, and then you can assign readings in the inspection plan. And in fact, the way to do that is that I'm going to actually add a data file to the asset that I've been working on. So let's go to this data file, and we're going to add that to the asset. Remember this question, how many digits? For me, I know there's only 3. We'll use the default. The inspection information, and here's the information. This is familiar to you. Data collector name. We'll put my name in there. I'll use the right keyboard this time. The child file type is a reinforcing. And notice when I clicked reinforcing, this selection showed up. So we'll get to that one in just a second. Were the readings taken after a repair or modification? No. What's the section? In this case, shell at 0.5 meter elevation. I did that again. 0.5 meter elevation. Repad. This is small nozzles. Now, I can select a circular, which is normal for a large repad like a manway. Multiple small repads, that would be for ladder connections and so on, or multiple small nozzles. They've got to be less than 12 inches. I click on that, and in fact, it even removes the need for writing small nozzles in there. The corrosion barrier construction is FRP. It's hand layup. I don't know how thick the laminate is. We took the readings from the outer surface. Tank was empty when we did it, and I don't have any particular information to add in the reading locations and details, but in fact, we'll be able to add them into the inspection plan. So we have to keep track of them when we do it. Certification is complete, and the next question that comes up is what type of delay line was used, and in this case, we use the DL line, not the rad line. And if you have a chance to measure yours when you use it, by all means do it. The one I used was 16.667 millimeters, and the material designation is UTComp. Now, what comes up next is what readings were included in this, what readings are included in the file. And so we get a chance to see all of the readings. And I think you've seen this before. This is a bare transducer reading, and you kind of tell from the way it looks. I was scrolling through them, getting some information, another bare transducer reading. They all look fine to me. I'm going to say okay. Do I want to delete any readings? No. You'll be presented with this. It'll be a picture of the bare transducer readings that that we infer or guess came from the file. And in fact, you now have a chance to select which ones really are bare transducer readings. One of them, the first one, the last one, both of them, or maybe none. In this case, both of them are bare. And we say, okay. I think we present you with the calibration readings. This is what they look like. They both match, and they match so closely you can't tell one apart. So we'll say use both. And it's asking me to confirm whether or not double hit was used. And so after I get that, I say, okay, I've got this many readings. Okay. So what do we do next? We haven't put anything into the inspection plan. Well, the way we address that, as I pull this over, I click on File, and I view or edit the inspection. So up comes the inspection plan again. And the small nozzle that I dealt with, it's only one that I was dealing with on that. I could add another one, actually. Let me do that. There. I just added another small nozzle. I'm going to say, let's copy the information from CML3, which is giving me the same information. We'll update that. And that's nozzle N2. We'll add that CML. Now, we know that we've just added a file for small nozzles, 03 and 04. I don't have small nozzles shown on this image, so that's why we don't see them there. But now, if you look here, you say we can see a section for reading selection, just like we'd have for piping. So select which data file was collected at this CML. Well, multiple nozzles number 1. The software named it that. And in fact, we're going to say that these 3 readings, 2, 3, and 4, were for nozzle N1, which is the one I'm showing with CML3. And I'm going to say done, which it was a mistake because I actually, instead of I closed the inspection plan. So I've just reopened it. It saved that information. Now I want to go to the next CML, and CML4, we can see that there are 4 readings left. We're going to keep track of those and put them on there. We can also assign readings for CML 01 and 02. We could assign the readings from the files from those on the inspection plan. It's not as important for those ones because 01 is for the shell around the circumference, and 02 is for a single circular repad. So it's not as important. We don't have to keep track of them that way. If you want to add the readings there, you certainly can. But it's important for the multiple nozzles because then we're able to identify what readings belong to which nozzles. Or for small repads that might be used for supports or for hold down lugs, we also can keep track of the individual ones. Once we've completed all of this, now we can save this inspection plan, we can save the worksheet or the document, but at this point I'm going to say it's done. We're now ready to save the asset. So do I want to save the asset with the updated inspection plan? Yes, I do want to do that, and I'm going to mark that as January 8th. We'll save it, and it's ready to be uploaded. Okay. So, again, repeat. Make each CML, each one of these repads its own CML or condition monitoring location and get the readings from them, and then record that information and record which readings were taken on the inspection plan. All right, you're finished. Of course, any questions, any feedback you have, send it to me, gclarkson@utcomp.ca. And when you finish this video training, would you please send an email to Joanne stating that you've completed the video training for V6 of the interface program. That helps us keep up to date with who's done this, who's got the who's up to date with their training, and helps us find any issues. Well, I thank you very much for spending some time with me as I went through this. This has been a fun experience for me, and I hope that it works for you guys. Best of luck.